SwayamPrabha. Digital India. Educated India.
Good morning. Welcome to the second lecture of fourth week for this ongoing online course, which is Understanding and Reducing Greenhouse Gas Emissions and a focus on scope 1 and 2 emissions through building design and construction. This is the second lecture of this week, and yesterday we looked at the India specific GHG programs, and in that lecture we looked at the India GHG program. We looked at the standards and guidelines that they have compiled, and also we went through the calculation tools for different sectors for different specific products. So, that is what we have seen. Today in this particular lecture we are going to look at the GHG platform India, which is a part or a product which was developed as part of India GHG program, sector wise emission estimates, state wise emissions, and also methodology of each sector for few sectors that we are going to cover. So, if we look at the GHG platform India, so India GHG program is the voluntary industry led program, and GHG platform is a platform that puts together a lot of resources here. So, there are tools, calculation tools, accounting tools which are developed by India GHG program, which is an industry led membership voluntary program. This is also civil society initiative, it is a collective initiative, but less of industry led, it is more of a civil society initiative. This was jointly conceptualized by Shakti Sustainable Energy Foundation, which is one of the supporting organizations to India GHG program, and also Vasudha Foundation. So, these two foundations, they conceptualized this platform, and the key sector that this platform includes, it is energy, industry, agriculture, forest and other land uses, and waste sectors. So, primarily these sectors are being covered on this platform, and it hosts national and sub-national estimates for GHG emissions from 2005 onwards, by accounting for carbon dioxide, methane and nitrous oxide. It also undertakes analytical assessments to inform policy design and evaluation. So, India GHG program is an industry led program, and it is a voluntary program. This is also voluntary, but this is more of a platform which is making the resources available. Very similar kind of work they are doing, but here on this platform we would find the emission estimates, while for that one they actually provide the calculation tools. Here we would find that they are estimating the emissions for different states, different sectors, India as a country, and different other levels. So, this particular platform, it includes the contributions of various notable institutions such as Council on Energy, Environment and Water, Center for Study of Science, Technology and Policy, ICLEI, Local Governments for Sustainability South Asia, Vasudha Foundation, World Resource Institute India. WRI is also a contributing institute to the GHG platform program, India GHG program, and it is also a contributing institute to the platform, GHG platform here. The International Maize and Wheat Improvement Center. Now, this particular platform, it actually drew inspiration from a similar platform which was existing and in use in Brazil, which was named System for Estimation of Emissions of GHG, SEEG. SEEG, it is a wonderful example of South-South cooperation, and the India platform, it benefits from the Brazilian expertise and technical inputs which was existing, pre-existing before this India GHG platform was formulated. So, the mission is, and it supports the government of India's efforts towards submitting national communications to the United Nations FCCC. So, since India has committed itself towards reaching a net zero status, net zero emissions status, so it needs to report to UNFCCC on its progress, the data, the various communications have to be made. So, GHG platform, India GHG platform supports government of India in doing that, and for doing so they have to estimate the emissions that are happening in different states at different governance levels and as a country. So, mainly filling the data gaps, helping the government with formulating the related policies, also taking from the industry led initiatives the emissions that are coming from there, and putting all of it together to estimate the overall emissions. Now, understand that when we are talking about calculating the emissions for one single company, and it requires a rigorous process to be followed, several steps, multiple types of emissions to be all put together and accurately, that is only for one industry. When we talk about smallest governance level, for example, we are talking about say a city, which is not the smallest governance level, but if we consider city, within the city there would be hundreds of industries, residences will be there, transportation, services, infrastructure, a lot of these things are together in a system which is within the city. Now, if we have to know, calculate the emissions for the city, we have to estimate the emissions for all of them, and it is not an easy task. So, there are methodologies which are available internationally, some standards and guidelines are available, protocols are available. We can follow them to estimate the emissions that are happening at each of these levels. The primary aim of this India GHG platform is to help government in estimating these emissions, filling the data gaps, enhancing the data accessibility, and then on the basis of that informing policy dialogue and showcase India's actions on climate change. So, they are supporting government on all of this. So, there is, if we clearly understand, there is a slight difference between the India GHG program, which is an industry led program, and India GHG platform. The previous one which we saw yesterday is an industry led program, where we are trying to estimate the emissions, GHG emissions resulting from different activities, different industries, and we are actually coming down to specific numbers for smaller activity, for smaller industry or sector. Here we are talking about a large scale, and we are trying to estimate the number for each governance level. That is the difference. Now, here if we look at the target 2030, we are hoping that from the baseline year of 2005, we would have reduced the GDP intensity, the emission intensity of GDP by 45%. However, if we look at 2018 data, from 2005 level, the estimates say, as per the GHG platform, that the emission intensity has already reduced by 22%, and we will see that what is the basis of making such claims and where are these numbers coming from. So, what they did sector wise emission estimates. So, as I said that this platform is actually estimating broad emission estimates. So, first one we will look at sector wise emission estimates. So, if we look at the economy wide emissions in 2018 with a baseline of 2005. So, we have already seen what a baseline year would mean and how we calculate from that baseline year. So, looking at the economy wide emissions in 2018 and going by the numbers that are calculated by India GHG platform, we would see that the maximum percentage of emissions is resulting from energy sector, followed by agricultural, forestry and other land uses, and then industrial processes, and lastly the waste. Further, each one of these, they have been divided into different activities. So, for example, energy, the large percentage of emissions is actually coming from fuel consumption, but a very small part is also resulting from the fuel production and the fugitive emissions that are also going as part of the energy sector. So, and then further, if we look at the fuel combustion, where all for energy itself the fuel is being combusted. So, we will see it is going in transportation, it is going in captive power, it is going in residential, it is going in public electricity generation, which is the biggest chunk, and then the industries. So, industries are coming within this for energy as a sector. So, energy in industries is being treated as one sector, and that is the primary contributor to the GHG emissions in India. And that is what we have to keep in mind, because when we move forward and we look at how we can reduce the scope 1 and 2 emissions through building design and construction, we clearly see that we are aiming at reducing the energy consumption directly, and sometimes it will be direct emissions, but most of the time it will be scope 2 emissions which will be targeted if we reduce the energy consumption. And looking at it, it is the most significant contributor of GHG emissions, the energy production consumption. And then we have the agriculture, forestry and other land uses, where we are talking the largest share is actually coming from livestock. How they have arrived at these emission numbers we will see in the later part of today's lecture, which is on methodology, but livestock is a significant contributor. We might otherwise be thinking that how within agricultural forestry, why is it an emitter? It should rather be a sequester, it should be taking the carbon dioxide, it should be absorbing it and acting as a sink. But actually forests do act as carbon sinks, but when we have agricultural, forestry and other land uses, especially where we are talking about farming and husbandry, there the livestock and also agricultural practices, they result in GHG emissions and do not really act as carbon sequesters or carbon sinks. So, agricultural, forestry and land use, and then we have industrial processes. Contrary to our thinking that industrial processes release a lot of greenhouse gas emissions, the direct greenhouse gas emissions resulting from industrial processes, industrial units is significantly lower than the emissions that are released due to energy production and the fuel combustion for energy production. So, yes, and of this energy that is being produced, the fuel that is combusted to produce this energy, a large percentage of this energy is actually going for industries, industrial use. So, yes, industries do contribute significantly towards the GHG emissions which are happening in energy sector also. Energy sector is not producing energy for its own consumption. It is producing energy to be consumed by industries, by agriculture, by residences, by commercial, by every other sector. But if we look at the direct emissions, the direct emissions are maximum coming from the energy sector, and industrial processes and units, they are producing significant amount, but considerably smaller than the energy sector. So, there are different types of industries. We will go in detail over each one of these sectors. And the last one, which is quite alarming for a country like India, is the fourth sector, which is actually that of waste. There are significant direct emissions which are resulting from the waste. We are not managing our waste properly due to unscientific disposal of the waste on land, in water. A lot of emissions are released when the waste decomposes and the combustion happens on its own when it is exposed to the environment. So, waste is responsible for maximum amount of emissions. Unscientific, there is no control over emissions. Even when it is a scientific waste disposal, there also through the process emissions, GHG emissions are happening. So, this is what we are looking at. Overall, we have to focus. Now, this is giving us a direction. We have to focus on energy sector. Like many other countries, for example, Spain, we have to depend less on conventional fuels for generating electricity. So, if we reduce the fuel consumption from energy sector, the energy sector, the GHG emissions from energy sector will significantly reduce without compromising on availability of energy, and that is the direction which the government already is following through various national missions, National Solar Mission and others, where we are emphasizing more on installation of solar farms, solar power farms. We are in the process of constructing more and more hydro power dams. We are looking at wind farms, we are looking at the biofuels and tidal energies. So, all of these renewable forms of energies need to replace the combustion of fuel for generating energy. Now, within this, if we go in detail, they have gone ahead and estimated the amount of different various gases that are being emitted. So, if we look at this, we have carbon dioxide, we have nitrogen dioxide and we also have methane. Now, here when we look at the emissions of these gases, their carbon dioxide equivalents will all be put together to understand how much of GHG emissions this sector is causing. So, overall if we look at this chart here, we will see that 83% of the net emissions are actually coming from the energy sector, and within that we have these main gases which are there, carbon dioxide being the primary gas, and also significant amount of methane is being generated through the combustion of fuel. Now, within this, if we will look at the emissions and calculate the emissions, a lot of coal in India for producing electricity is imported from different destinations across the world. If the coal is homegrown, it is procured from the country itself, the emissions would be different, the emission per unit of electricity produced would be different in comparison to when the fuel itself is coming from a large distance, for example, from Australia. Now, all the transportation costs and the emissions which are added to the per unit electricity production and the GHG emissions that are associated with it. So, we have to go into those details, and that is what has been done to estimate this number. So, this was for economy wide emissions. Now, if we look at each specific sector, so for example, energy here, energy is contributing to 83% of the total GHG emissions of the entire economy for India. If we look at the 100% of energy here, as I had said that fuel combustion is the primary cause of GHG emissions for producing electricity, but there are also fugitive emissions. We have already studied about fugitive emissions, you can go back to the lecture and see. So, there are some fugitive emissions, very small part, but large percentage of this is actually coming through the fuel combustion. Now, this fuel combustion which is generating electricity is for industries, which is a significant share, but primarily public electricity generation, which is going for running of habitable areas, residences, commercial buildings, street lighting, all other services and infrastructure that is run on electricity is supplied electricity by public electricity generation, and that is the major contributor. Now, this is what we have to, this is something that can be addressed easily and directly, this is a low hanging fruit. We have to reduce the energy consumption by, and it is easier because it is dependent upon the lifestyle, it is dependent upon the choices that we make, the equipments that we purchase, the appliances that we purchase. So, Bureau of Energy Efficiency comes up with this star rating, and it encourages people to choose the higher star rated product which is consuming, which results in lower energy consumption. all these smaller steps, replacing your traditional CFLs or incandescent bulbs and lights with those of LEDs. So, gradually the government through policy initiatives is also moving towards these, but we are looking at reducing this public electricity generation and further consumption. So, what we are going to see in this particular part in the subsequent lectures in the coming weeks is how we can reduce this through building design. So, this is what we are primarily looking at, and there is a significant potential of reducing this energy consumption, the demand for energy, through appropriately designing the buildings and also constructing them. Besides this, the electricity, the energy that is being produced is going for transportation, for captive power plants and also for residential purposes. So, altogether if we look at the energy that is consumed in buildings, and if we look at the data which we will come to, it is approximately 25% of the total energy that is consumed in the country, that is actually going in maintaining the comfortable environments inside the buildings alone. They will be multiple purposes, they will be serving multiple purposes, residential, commercial, other purposes where humans are living, not the industrial buildings. So, all these contribute or consume around 25% of the energy, and hence building design is an activity, it is a task that needs to be looked at very, very carefully. So, the gases that are released because of energy, so these are methane, carbon dioxide and NOx. So, this is how the distribution is happening, and overall if we look at this, around 45% of the energy that is generated or the GHG emissions that are happening because of energy generation are for public electricity generation, and others industries around 26%, transportation 12%, we have residential which is coming to 5%, we also have fugitive emissions, captive power plants, agriculture, commercial, but very small percentages, but largely looking at public electricity generation. Looking at the second important sector, not the largest, the second largest is agriculture, forestry and other land uses, but this is the second one, which is industrial processes and units, IPPU, and it contributes to around 7% of India's total GHG emissions. Now, here we are not talking about the emissions resulting from the electricity that is consumed, the energy that is consumed in these industrial processes and units. We are only talking about the direct emissions that are resulting from the processes that are happening within these industries. So, if we look at the industries, the largest share of GHG emissions is from mineral industry, and within that the largest share is from cement production. Now, again when I was talking about building design and construction, we have to, and there are several alternative materials which are available. Now, it also depends upon design, because as the cities are becoming denser and more populated, we need to go vertical, and there we have lesser choice of materials which can sustain. So, it is not just a building exercise, it is a planning exercise altogether if we want to develop the country in a manner that the use for energy intensive building materials such as cement, glass and steel itself is reduced, we can significantly cut down on greenhouse gas emissions through design and planning approach, building design and planning approach. So, in IPPU we see that the maximum contribution is GHG emission contribution is coming from cement sector, followed by iron and steel, followed by ammonia, and then there are others such as glass, aluminum, ethylene oxide and others. So, largely three industries: mineral, chemical and metal. And if you look at the contribution of these industries, you will see that most of the products that are being produced are actually going to be consumed in buildings. Cement, that is the maximum contributor, iron and steel production, and glass. Now, if I look at this share, I am looking at this share, that is around 75% of the total industrial processes and units that is being contributed GHG emissions, and this is actually going in our buildings predominantly. I am not saying 100% of the steel is going to be used in buildings, but largely it is going to get consumed in buildings and infrastructure related, civil related projects. Again, I emphasize that the way we design our buildings, the kind of materials that we propose, that we use in our buildings is going to affect the GHG emissions that our country is going to be having in future. And if we are looking at a safe future, a climate conducive future for our future generations to come, we have to start thinking about our buildings, how we are designing and how we are operating our buildings, our city, our habitable areas. So, it is very, very clear that we are focusing more and more, and we need to focus more and more on building design and construction. Again, the different GHG emissions. So, primarily largely you will see that a lot of contributions are actually in terms of carbon dioxide production, which is good as a news, better as a news, because if we have more methane and NOx and SOx being produced, their equivalent carbon is much higher. So, but otherwise overall the emissions are significantly higher, but they can be controlled, they can be reduced. Thirdly, we have this agricultural, forestry and other land uses, emissions coming from that, and here we have the maximum amount of emission which is coming from livestock. Livestock releases a lot of methane. So, a lot of research has already happened, and the livestock is significant contributor to methane. Followed by we have land, we have the other aggregate sources, and together all of the, if you put all of that together, and here you can see that the contribution of livestock is largely towards methane, and we know clearly that methane emission is more significant and powerful than carbon dioxide. So, here overall if we look at the first pie chart that we discussed, economy wide emissions, the agricultural, forestry and other land uses might be a slightly lesser percentage overall, but it has significant contribution due to the methane that is being produced as due to different agricultural and forestry processes, including livestock, which is the major contributor. Also, we have to see that this livestock in India is going into different categories or purposes. So, there is livestock for agriculture, there is livestock for food consumption, there is livestock for different purposes, for products development, for products manufacturing also. Now, we have to see where the lifestyle changes can bring a significant reduction to GHG emissions, and that is what we are subsequently be talking very briefly in the upcoming lectures of the coming weeks. The last one is this waste emissions, and in waste emissions we will be surprised to see that the domestic waste water is the primary contributor of GHG emissions. We would have thought that the solid waste disposal, which is what the general understanding is, would be the biggest contributor, but it is actually the domestic waste water which is the biggest contributor. This is a result of the changing lifestyle and habits. We are departing from the traditional lifestyle and moving more and more towards the urban lifestyle, and this wastewater releases a lot of emissions. Direct GHG emissions is what has been calculated. followed by industrial wastewater and then solid waste disposal. And again primarily, as I had said earlier also, all this contributes, the primary gases that it contributes is CH4, methane. No carbon dioxide, and the overall emission equivalent, carbon dioxide equivalent we will calculate will be much higher. So, waste, but the good side of it is, the bright side of it is that it can be managed. It is an activity, it is an infrastructure service, and we can manage our domestic wastewater, our solid waste. Again we have to look at the conventional ways vis-a-vis the traditional ways and the technologically enabled ways, where no wastewater dumping or releasing in the streams or proper treatment of it has to take place at every household level. So, this is what we are looking at. This was sector wise emission. Now, if we look at the state wise emission, this is very interesting data. I will quickly go through it. You can go to the India GHG platform and see a lot of information that is available. So, looking at overall economy wide emissions, Uttar Pradesh tops the emissions. Maximum emissions are coming from Uttar Pradesh, Maharashtra and Gujarat. So, a lot of industries, agriculture and power is being generated is what is understood overall economy wide emissions if we see. If we look at the top 10 states in energy emissions, we can clearly see that the top state in energy emissions is Orissa, followed by Maharashtra, followed by Chhattisgarh, and it gives us a clear idea where the thermal power plants are situated. So, it is only energy production. So, fuel consumption for energy production is what we are looking at here. These are not the consumer states, we are looking at energy emissions. So, this data clearly tells us where the fuel is being burnt to produce energy. If we look at IPPU emissions, this tells us about the state which is most industrialized, where maximum industrial units are coming. So, Gujarat, it tops, it must be having the maximum energy units, industrial units, and hence the direct GHG emissions resulting from industrial processes are coming from there. We have surprisingly Rajasthan, which is second. A lot of industrial units processes are happening in these states, followed by Maharashtra and so on. Again, in agricultural, forestry and other land uses, we see that Uttar Pradesh leads and significantly ahead of all other states, which means that the emissions resulting from agricultural and animal livestock husbandry activities is maximum in Uttar Pradesh. If we go in detail over where exactly are these emissions, agricultural forestry emissions in Uttar Pradesh are coming from, we can have a clear idea as to what are the activities that are causing these emissions. Again, in waste emissions, and we have clearly seen that it is because of the domestic wastewater, it is again Uttar Pradesh is on the top. So, overall if you will see, the overall maximum amount of emissions are resulting in they are happening in Uttar Pradesh, and that will also be, it can be correlated to the air quality and the water quality, the soil quality of a state. If more emissions are happening, it is more likely to be having a polluted state of different resources. Now, this is the last section of this particular lecture, where we are quickly discussing the methodology for each sector. You must be wondering that how is it possible to calculate for emissions for an entire state or emissions for an entire sector. So, this methodology is clearly defined by IPCC. So, there are other guidelines and standards are also available for all these different sectors: energy, industry, agriculture and waste. Different guidelines, reporting formats and accounting formats, they have been proposed, prescribed, and they have been used. For electricity and energy sector, the estimations, they follow IPCC 2006 reporting format here clearly, and a lot of data is coming from the existing statistical program. Now, when we were looking in the previous lecture, when we were looking at some of the calculation tools, so there the calculations, the detailed calculations for each of the process and how much of the emissions will be accruing from that, they will be done in the background and the simplified equations have been carried forward. Putting the simpler data of say production of a particular product, or in this particular case maybe the area, the amount of electricity that has been produced and things. So, simple numbers when we put, they will be helping us achieve this emission data from electricity and energy sector. Primarily the data was coming from different databases which existed, such as Ministry of Statistics and Program Implementation, the National Sample Survey Organization's data, and from different ministries such as Ministry of Coal, Ministry of Petroleum and Natural Gas, and also from research organizations such as TERI Study Yearbooks or ICF International Infrastructure Development and Finance Company, IDFC's research studies. So, putting together a lot of research data, sets and statistical data from government sources, research centers, from different industries, from different corporates, and all of them have been put together using the methodology that has been proposed as per IPCC 2006 reporting format, and that is how electricity and energy sector emissions have been estimated. For industry, again IPCC 2006 reporting format has been used, and the unit level data set of Annual Survey of Industries ASI, that has been used as the prime source of information for estimating industrial energy use. So, this Annual Survey of Industries, it puts together a lot of data from all types of industries, different types of industries, their emissions, their production level, their processes, and that has been used as the information to calculate the industry's sector emissions. For agricultural and forestry emissions, again IPCC 1996, 2006 and 2019, 3 guidelines they have been used, and country specific emission factors they have been used instead of IPCC default emission factors. In some places where the country specific emission factors were not available, there the default IPCC emission factors they have been used. What India GHG program is doing, it is developing the country specific emission factors, which is a significant contribution. What GHG platform is doing, it is putting together all these emission factors and calculating the emission data for different states, sectors, nation, cities and all that. So, that is how for agriculture sector we have calculated, and lastly for the waste sector, and which we have clearly identified that domestic wastewater is the primary activity within the waste sector, which is contributing towards majority of the emissions. So, overall different methodologies have been followed for different sectors, different emission factors have been used for each of these sectors, sometimes the default ones as per IPCC, sometimes the nation specific ones, but the data is clearly available as to how the overall emissions for each sector have been arrived at, and then subsequently for the state and nation. So, this is all about India specific GHG program. I hope we have an understanding and an overview of what is happening in the country today as far as GHG program is concerned, but it also surely gives us this picture that a lot of momentum is there, and collectively the industry, corporates, businesses, government, states, they are all moving together in the same direction. Of course, their intents and aims vary slightly depending upon the position they are in, but it is a collective effort, and so we can be positive about the outcomes that we are very soon going to reach the target which the nation has set for itself of becoming a net zero emission, and it is in the benefit of mankind at large. So, I will conclude my lecture here today. See you again tomorrow in the third lecture of this week. Till then, bye bye.